Okay, here's an HL question. We're being told that we have a pure sample which has an activity, a pure sample with that mass, okay? We have an activity of 2.5 times 10 to the 16 becquerels, and we want to know what is the decay constant. As ever, please have a look at the question, and when we're ready to go, let's see the answer. Okay, so we want to know decay constant. By the way, HL here, so SL, feel free to duck out if you've not already done so. Let's look at what we know here. We know the relationships here between our decay constant and our numbers of particles. The activity is related to the number of particles by lambda times n. In other words, if I know lambda and know n, I can multiply them together to get our activity. In this case, we want to know decay constant. That's our probability of decay per unit time. That's just the ratio of activity to the number of particles that we have here. Now, the difficult bit here is we don't know how many particles we have. We know the activity, but we don't know the number of particles. To get this, we're going to use our number of moles. Okay, we know that we have Avogadro's number, Na, that's the number of particles in each mole, but we also know the total mass, 4.4. We also know that the molar mass of this thing is going to have the same as this nucleon number, 222. And so what we're going to do, we're going to be working here in grams. 4.4 divided by 222 times 6.02 times 10 to the 23 gives me 1.19 times 10 to the 23. Okay, we're then going to take that number and put it back into our original equation, 2.5 times 10 to the 16 divided by our 1.1, which gives me 2.1 times 10 to the minus 6, and our answer here is C.